And welcome back. So you can see we're back inside of our parts RAM here. What we're going to do in this video is hopefully finish tracking down the rest of our wiring that we need and getting it unclipped, removed from this factory harness, so that way we can graft it over into the harness of our 2012. Now earlier when we looked at this is two of the ones we're going to need, which is our IHS CAN circuit. So we know we're going to need those. Earlier we spoke about this one, which is just power and grounds to the center console, which is already in the 2012. We don't need that connector. But we're also going to need this big 20-pin connector, which has a lot of the feeds that go over into our passenger seat. Now, our passenger seat connector has some wiring in it that goes to the inverter, which we're not going to use in the 2012. So we'll just clip those wires and leave us a little bit of length, and we'll kind of just tuck those off to the side. So in the future, if we wish to add in that type of a feature, then we'll have a little bit of a pigtail, so to speak, on the passenger side to deal with. But what I'm going to do is I'm going to start off with our 14-pin connector here and kind of go through it and figure out which ones we need to keep and which ones can stay. Some of these, it's either on this one or on the 20-pin, but some of these are the heated steering wheel and the temperature sensor for the heated steering wheel. And I'm not going to take this steering wheel off of here and go into our 2012 with it, because it's got the other set of buttons on it, which doesn't have all of the functionality of the steering wheel that the 2012 has. So in theory, if we wanted to, we could potentially take this steering wheel apart and switch the switch banks around, but I'm not really overly concerned with having a heated steering wheel per se inside the 2012. So what we're going to do is we're just going to identify those wires again. We'll cut them a little bit to length, and then we'll just seal them off with some heat shrink, and that way we have a little bit of a pigtail. So in the event that we do elect to get a heated steering wheel later, then we can potentially just graft it into our 2012. Because along with the heated steering wheel, and what I'm looking for now is there's supposed to be a module, a heated steering wheel module, somewhere up within the dash here, at least per the wiring diagrams. There's an additional module besides just the heated seat module underneath the driver's seat, but I'm not seeing it at least obviously accessible. Either way, what I'm going to do is we're going to focus on getting more of this wiring looked at, cut down, compare that with our wiring diagrams, and just do some snipping here. And even on this factory harness here, if I like this, for instance, is going to get trimmed, but what we're going to do is we're going to take the factory harness side of this and just put a piece of heat shrink on it and just seal the ends off. That way, at least even on our Ram here, even though it's never going to go on the road again, and I don't want one of these lines here, which this one happens to be positive 12 volts all the time, just to be bare and exposed and inadvertently blow a fuse for no reason. So I'm going to get to work on this, and once again, just going to be looking over that's for our passenger seat. Should have one in here for our driver. Yeah, that is our left seat too. So that's our 2010. That's our 20-pin. The driver's side, and we should have a left seat 1, which is the 2010 14-pin connector that we're going to need. And that's a 351, that's a 14-pin. Yeah, seat right too. Okay, yeah, seat right. Okay, so we're getting into some of the diagrams being the 2012. Okay, so we don't need these, but we do need these. And again, like I said before, and I know I keep restating this, but all I'm going to do is go through this one. each one connector by connector, figure out if it's a wire that we need or not. If it's one that we're going to need, I'll trace it down as far as I can in the harness just to give us a nice bit of leadway, nice bit of extra run, clip it, and then we'll use that pigtail, so to speak, and start looking at how we're going to graft this into our 2012. But with that being said, I'll bring you back. One moment. And welcome back. So we just went through our wiring harnesses for both our driver and passenger side here, and just to kind of show you what I'm doing, yeah, hopefully you can see these three here, a bit of a shadow. And as we snip them, if it's something that's still left on the main wiring bundle, we're just putting a little piece of heat shrink on it, heating it up, and then pinching the end, and that way it'll seal the wire up. Because again, you know, even though this truck won't be on the road again, we don't want to do something that's going to cause a short, blow some fuses, or maybe damage something else on the truck that we need in order to, you know, still make it run and drive. So we've done that throughout here. And just to show you on the driver's side, you can see more of that over there in that wiring harness. Again, just as we clip the harness out, we just cap the ends off where we could. And what we end up with is what you see here. So this is the passenger side and its connector. And you can see what we're also left with over here, which is what came off the driver's side, is 14 and 20 pin connector. But more importantly, by kind of systematically going through it and making sure that we're on the right ones here, get a better indication of it on this one. You can see there's about 5 wire strands there that go, again, between that 20 pin plug on the driver's side and the 14 pin plug that'll be on the passenger side. Now all we got to do now is take this harness, finish weeding out the wires that we won't use, go ahead and leave those capped, and start tying in the ones that we're going to need. Because there were several wires that we cut on there that we capped that we're actually not even going to use in our 2012, and one of those being power for the inverter, the 110 volt inverter output we don't need, the indicator, the driver. And on the driver's side, inside its plug and its harness, one of the plugs, it had a lot of options on it for seat memory, which wasn't even an option on this truck. So it looks like it was wired into the connector and just not used. It also had the wiring that goes up to the heated steering wheel, as well as the temperature return. Remember, we're not going to use that. So there's going to be quite a bit of wiring on both these driver's side connectors, that what we're going to do is just cap them off with a piece of heat shrink once we get everything ready and wired in, and that way we'll just kind of wrap them up inside the wiring harness and just leave them there. And in the event that we want to add that feature in the future, then we have, at least, as you can see, you know, we have a little bit of a pigtail now coming off of our connector that we can then splice our wiring into. But with that being said, let me go ahead and wrap things up here, and then bring you back when we're inside of our 2012. One moment. And welcome back. So you can see we've got our wiring harnesses that we removed out of our 2010, just kind of laying inside of our 2012 here, just getting everything situated. So if you remember, this was our 20 pin connector off the driver's side harness out of our 2010, and just using the description of the wiring diagram, remember we went through and looked at the majority of these, and basically everything you see here on this connector that's just been cut from the previous harness, we're actually not going to use in this 2010, because a lot of these go to options that this truck doesn't have, such as the heated steering wheel, which we weren't going to use. This harness was also pre-wired in the 2010 for having the movable pedals. In other words, in some Rams, if you remember our 2009, had pedals that would go up or come down and kind of be adjustable. And this had provisions for that. And the reason why it did was that this also has provisions inside of this harness for a memory module that was an option that would have normally been underneath the driver's seat in the 2010, that would allow you to basically preset the seat since it was powered. If you had powered pedals, preset the height, and when you unlocked the truck, it would return the seat and the pedals to a predetermined set point. Now, even though the 2010 didn't have the adjustable pedals or the memory module in it, it looks like it was pre-wired for it, and that's what makes up the majority of these wires on this 20-pin connector on the driver's side. So all of these you see here, we'll just be getting these capped with a piece of heat shrink so they don't inadvertently short. And then what we'll do for the remaining connectors, you see, all run across here, and they go to our passenger side connector. So for this one, we just have to get the unused wires capped and ready to be kind of tucked into the rest of the loom, and there's really nothing else we have to do with this one. Now, this connector you see here, this 14-pin connector out of our donor RAM, is going to replace the 14-pin connector that's already in our 2010. And what's inside the connector for the 2010 are the 2 wires for the seat belt monitor for the driver's side and a ground wire. So what we're going to do is we're going to basically remove this connector. We're going to strip back a little bit of this harness so we can gain access to some extra wire, and then we're just going to splice in our seatbelt wiring and our 1 ground wire since it's already run for us, and then that way all we have to do is accommodate for the rest of them. This green one that you see here, you'll notice its colors match. This came out of the donor RAM. This coloring matches our coloring here. So it looks like we got a green with orange and a green with white. And you'll see that we've got a green with white and a green with orange. So basically this is our seat belt switch off our 2010 seats. So literally we're just going to graft it wire for wire onto the green ones here. We've got a couple of grounds that also come off of this one here. And we're just going to graft this one, and maybe you can see that there. So this is out of a 2010, so that's a ground wire, and our seatbelt wires are next to it. And if you look at what's inside our 2012, you can see that first one's also ground wire and the seatbelt. So those 3 wires we're just going to cut here, give us a little bit of slack, then we'll cut it, and we'll just graft those at least first 3 wires onto this existing harness, and then we just have to come up with powers for the remaining of this. And the white wires that you see there, we'll get into it. I don't want to go through one by one at this point in time. We'll kind of address it as we come up to the need. But you can see we've got some of our harness already untaped and stripped back here, because there is that CAN IHS bus, which should be these 2 wires here, our white and our gray and our white and our orange, that we're going to need to tap into in order to have the rest of the truck be able to talk to the heated seat module that we're getting ready to put in. But for now, again, what we're going to do, I'm going to strip a little bit of this harness back, get this connector clipped out of here, and then we'll prep it to marry in to our new 14-pin connector. Let's see. And these, it's simple enough. Remember, we just have to cap them. So let me get to work on that. I'm going to get this stripped back, and I'll bring you back. One moment. And welcome back. So you can see we're just getting everything set up here, getting ready to have everything tinned, because yes, I'm going to use solder and heat shrink on there to make these connections together. I don't want to use butt splices in this case, not that I have anything against them, but with all this wiring potentially going to be either underneath a loom or underneath a piece of carpet, something along that nature, and I don't want to have a butt splice on there that could potentially mechanically fail. Again, not that I think that it would, but I would just, at least make myself personally, feel a bit more secure with this, again, being covered under carpet and such, potentially covered under the carpet and such, that these connections just be soldered and heat shrink together. But to each their own. If you choose to use the butt splice terminals, it's fine. I'd suggest that if you're going to use those, that you get the kind that at least will heat shrink around the connection and contain the sealant in them to help seal the connection up. But we're just prepping to marry the seat belt indicator off our new connector on our existing harness. Now, this was the connector that we cut off. This was the old 2010 connector. All it had was the seat belt monitoring lines and a ground. Yes, and we did cut that a little bit short, but again, we had a connector we're going to graft on. So you can see I'm leaving the rather generous amount of wire on here. Matter of fact, I think, actually, I'll be honest with you, I may, when we cut the camera, I may come and cut about half of this wire off, and that'll still give us quite a bit of slack. But in this case, this particular join up is relatively straightforward. We're just matching color code for color code. Now, this ground that was already on here, I commented on earlier, since this truck didn't have powered seats, this is a relatively light gauge wire for the ground wire. This ground wire actually wasn't even being used on this seat. The only problem is we can't use it because it's too light of a gauge. This is like a 20 gauge wire, and I think what should be on here is more like a 14 gauge wire. You can actually see the thickness in that ground wire versus the thickness in what it should be, which is more like that. Hopefully the camera does that justice. So what we're going to do is I'm just going to splice into this cutoff ground line just a small enough thing of wire to get it to match up where we can bolt it onto this ground, this existing ground stud here. Because even in our 2010, this is where all the grounds ran for all the seat connections, was to this central point here. So we're going to do basically the same thing. But again, I can't use their wire because it's just too light of a gauge to return the current necessary to run the powered seats that we're going to be putting in here, because this ground is for the powered seats, and the grounding for the heated seats and such is done through, I think it's actually done through the same wire, maybe the same wire for the power as well as the heated seats. But either way, this is significantly thicker gauge than what came out of the 2010, so we can't use this one. So this will just get capped off and taped to the harness as an unused wire, and like I said, we'll lengthen this wire a little bit and run it to a ground point. But what I'm going to do is I'm going to trim these back, and yes, anytime you're doing the soldering work and using heat shrink, make sure you put your heat shrink on there before you make your solder connections. Ask me how I know. Trust me, I've done it enough times. When you make a really good solder connection, you look down and go, oh crap, I forgot to put my heat shrink on. Then you got to undo your connection and redo it. So that's where it's at. I'm going to go ahead and get these tinned up and get these soldered. In case you're wondering what I'm using, I'm just using good old-fashioned 60-40 lead-based solder. I'm using a little bit of liquid flux here on our wiring to help these tin up real well. And it's just 60-40. I know they make silver solder out there, but when it comes to electronics, things of that nature, I just prefer the old school 60-40 solder. I think it flows a little bit better, and in my opinion works a little bit better with electronics. And I have used silver solder in the past, but in this application we're going to use good old 60-40. We're just going to be mindful not to breathe any fumes in while we're doing this. I'm going to go ahead and work on getting this connection straightened out, and I'll bring you back and show you what it looks like when it's done. One moment. And welcome back. So you can see we've got our two seat belt wires grafted in. Just need to cover them up with some heat shrink and get them shrunk down. And then we have to accommodate for the rest of the wiring on our harness. Now we've got two purple ones here that I wanted to comment on, which, looking at the connector face, looks like it's going to be pin 2 and pin 8, 9, 10, 11. Pins 2 and 11 And looking at our sheet here, memory select switch return and memory select switch mux. So these two purple wires off this 14-pin connector, again, we're just going to trim them, cap them, because we don't have the memory function in this 2012, and it actually wasn't even in the 2010 either, so it was just more kind of pre-wired items not being used. But the rest of these we'll have to account for. So we got our CAN IHS circuit lines, which are these two white ones here. So a white with orange and a white with gray. We got two pinks with a yellow. These are ignition battery positive, so they only have battery positive when the key's in ignition. We got a full-time battery positive, which comes in on this red one that you kind of see here. And then we got the ground wire that we spoke of earlier that we just need to lengthen a little bit in order to finish making it back to that center bolt. So that's what I'm going to concentrate on. I'm going to go ahead and get these two purple wires just, again, trimmed up and capped off so we don't have to worry about them. And I think the next thing we're going to do is potentially, we'll get this ground wire lengthened out with a piece of, and I believe it said it needed to be 20 gauge, which we've got some boxes of wire here that I'll put a link in the description for. And it looks like we've got some 14 gauge here and some 18 gauge here. So what we may do is just put a small piece of 14 gauge on it, because this would be even a slightly bigger gauge than what this wire is here. Yeah, let's confirm that, shall we? So ground wire that came out of our 2010 looked like it's in pin 14. And according to this diagram, pin 14 is a 14 gauge ground that we need. So yeah, we got 14 gauge wire there. Perfect. So that'll marry up just fine. We'll cut about maybe a 1 foot piece of extension on it, and that will allow us to reach our ground lug there. So we're going to do that next. We're going to get these taken care of. We'll concentrate on this wire next, and I'll bring you back and show you what that looks like. One moment. And welcome back. So I just want to show you kind of what we got going on here. Is that as we spoke about, we went ahead and took all of our unneeded wiring, our pigtails, off of our 20 pin we weren't going to use. As you can see, we just put a little piece of heat shrink on it, heated up, and kind of pinched the ends shut just to seal it. We also cut all the ends even with each other. On the 14 pin for the driver's side, we went ahead and did the same with these two purple wires that we didn't need. And then we went on to go ahead and start extending out the wires we were going to keep. So our ground wire, we got a little bit of an extension on it. You can see it here. We kind of splice it into the main harness and put about an extra 2 or so feet on it. And again, that's just to allow us to run it from here to that center ground stud, which is, underneath where the console would sit. We also extended out these two power wires and gave them a rather fair length of slack for us to deal with. Now, these are the two that get 12 volts, but only when the key's in the ignition. And what we're going to do is, because on this one, they didn't run it. It looks like there is a fuse for these in the tip-em, but it doesn't look like they actually ran the actual power wires down the conduit. Now, I haven't taken this conduit completely apart, and to be honest with you, I don't really want to untape and undo all this. There could be a spare power line sitting there. There could not. It looks like it's possible, at least with this version of the cab harness, even though it's in the tip-em, the fuse box in the front of the engine compartment, it doesn't look like they've actually just ran that line out here. Now, probably the proper thing to do would be to, take apart the tip-em, find the pin if it's there. If it's not there, then extend it from the tip-em. But what we're going to do is a little bit different. So rather than have to keep from taking the entire fuse box in the engine compartment apart and running a wire, new wires either into that master connector you see there and pinning it back out, or running it, as you can see, not all the wiring that comes in from the engine compartment goes into this plug here. Some of it actually just comes out as straight up harness and continues to loop through, rather than trying to fight all that and dig through it. What we're going to do is we're going to run one main power line from the fuse box in the engine compartment up to a breakout point, which will sit inside the rear of the console. And I'll show you what we're going to do there when we get to it. Basically, we're going to take the rear power port out and reuse that line for our needs. And I think as long as it all works out, it should be pretty slick once it's done, in the sense that we're going to have a distribution block that'll be accessible by removing the rear panel off the center console, and inside of there is where we're going to tap our power from. So remember, we need one shared constant battery positive, which is the wire you see here that we took out of our 2010 that was already connecting the power seat power for left and right front seats, so basically driver and passenger, and it already came out to a central point that's spliced between the two connectors. So this is the main constant battery, 12 volts for the powered seats. You'll notice that is long enough because we cut it out of our 2010 harness right about here somewhere, because it did come from the fuse box. But we're going to run it down the center of this console, and that gives us enough slack to get to the distribution block we're going to have here. Now, inside the distribution block, we're also going to have two relayed outputs. The relayed outputs will get a trigger signal from the power port that we're going to remove from the back of the console. It's either going to be the back one or the front one. I have to go back and look at the video again. But one of the 12 volt outputs that's already accommodated for inside the connector here, as you see it, one of these 12 volt outputs that would normally feed either the rear or the front power port in that console is a keyed 12 volts. So we're going to kind of tap into that and use that to drive a pair of relays, which will then supply the keyed 12 volt power to our two extended pink wires, but the yellow tracer. Again, it doesn't matter which relay we hook these up to, they both just need to be a source of keyed 12 volts. That's why we got such a long extension on them, is so that we can route them this way, down through the center of the harness and over here, and give us plenty of slack to work with when we put the relays and the distribution block in. As obviously it won't stay quite that long, but it's, it's easier to subtract than add, when it comes into wiring. And we went ahead and, as you saw, that was our undersized ground wire that was in part of our existing harness. We're not going to be used. That's been capped off. Went ahead and heated up the heat shrink and got our seat belt wiring finished up there, and went ahead and also put some extension lane wires on our CAN circuit. This is our IHS CAN circuit, and as you can see there, we did our best to maintain the twist on this wire as it goes through. And what we're going to do is give ourselves plenty of slack, and we're going to tap in to the IHS CAN wires that you see right there. You'll see a white with a gray and a white with an orange, which match up with our white with a gray and white with an orange that we need. And inside the factory harness, what was happening was they tapped into it probably right about in here on our 2010, if I remember correctly, and we're more or less just going to do the same thing. So we put a little bit of extension on it. We won't use all of that extension, but again, we just wanted to have more than enough. And this one has a knot in it to signify to us that this one goes to the white with orange tracer. So when we go to hook these up, we make sure that we get them in the correct order, because this is a communication circuit. It is polarity sensitive. It does have a positive and negative to it. We do not want to tie into that circuit backwards. It would cause some rather interesting stuff to happen, or nothing to happen at all. One of the two. So that's what we're going to work on next, is kind of getting this situated. Well, more than likely, I'm going to come in here once we get things tested a little bit, and just kind of start grabbing these wires, as you see here, bundle them together, and then putting maybe 1 or 2 small tie wraps in here just to provide it some support, so we're not pulling it against it as much. We're going to do the same thing to here. We're just going to tie wrap these to the main wiring harness bundle. But that's what we're looking at. So next steps are going to be tapping into this CAN circuit here. And also we're going to have just 1 or 2 wires on the opposite side there that need to be maintained. The rest of the wiring that you see, there's a constant battery positive, but it went to the inverter under the seat that we're not going to use. And there were 1, 2, 3, 4 wires there that went to 2 of the wires are inverter output. So the 110 volt inverter output, again, we're not going to use. The other 2 wires, one was an inverter status light for the dash to get the light to come on. And the other one, I think, was part of the switching circuit to turn the inverter on. So there's 1, 2, 3, 4. There's 5 wires on the other side we're not going to use there. Since we're not going to need battery positive, there is no power to run to this side because remember, it's already run via the splice between the driver and passenger that you see there, the factory splice that we took out of our 2010. So we've got these 2 ground circuits that we're going to extend them both out to give us plenty of room. And again, we're just going to take those existing ground circuits, come up here and tie into the factory center ground you see that would normally be under that console. So that's what we're going to work on next. We're just going to continue to lengthen some wires, get stuff prepped in order to work on getting the distribution block and relay harness that'll go in here next. So when we get to that step, I'll explain a little bit more, but we can tap the ground for the new distribution block in that same point, and we'll just have to run a hot lead. What I'll more than likely do is just follow this existing channel down and then over, keeping possibly to just kind of tuck it maybe up underneath here, because I really don't want to break this existing channel apart, knowing how messy it gets when you pop this up. There's not very much room in here, but there should be enough room that we can kind of roll this up, and then we'll put some wire loom on it just to protect the wire, but looks like we got enough room. We can kind of push it down inside this channel, run it up, and then what we're going to do is, since it's equipped for having a clutch in here that we don't have, hopefully you can see that up in there, there is actually a plate right there held in by 2 bolts that we can unbolt, take that plate out, and just basically drill a small hole in it, and that will allow us to get our hot line in off of our battery out there in order to run it down in here, which will end up being the main feed to our distribution block. So that's what we're going to work on next. Again, I'll probably, since we got the soldering iron and everything out here still, yeah, I guess it really doesn't matter which way we do it. So you're not missing much. I haven't been filming a lot of the showing you of the splicing and the heat shrinking and the soldering, because soldering is almost as bad as talking about welding or torque values on a YouTube video. They tend to fall under a lot of scrutiny as far as if you don't do things exactly the way someone wants them to be done. So again, just stripping, coating them down with some rosin flux, tinning the wires, soldering it together, and then covering it with heat shrink. And that's kind of what we're ending up with, what you see there. We got to do the same thing on the CAN circuit and 2 ground wires, and that should take care of at least everything we need to extend. So I'm going to go ahead and continue to work on this. I'm going to go tap into this CAN circuit next. I'll show you what that looks like. We just want to be uber careful that we get nice solid connections on that, since that does involve talking to various modules on the inside. And no, I'm not fearful of tapping into this, because that's exactly how the factory does it. They literally just splice into here for the next module, goes on, splices in, feed for the next module, and so on and so forth. But again, we want to make sure that we get everything nice and proper, connected, mated up, no shorts when it comes to that, because we don't want really squirrely things happening. A little bit late in the video to say this, but obviously if you're looking at all this and it looks a little bit overwhelming and you're uncomfortable with doing the wiring, you may want to have somebody else assist you with it, or just bring it to somebody else to take care of your wiring. I mean, this looks a lot more complicated than what it is. It's a matter of following the pinouts, the color coding of the wiring, and it telling you what the wires need to go for, and then us determining what we need versus what we don't need. And yes, there is a little bit of experience that come with that, but there are several YouTube videos out there that if you've got questions on soldering tutorials, things of that nature, there's all kinds of them out there that'll kind of give you the basics of that. The last thing that we're going to look at, and we'll definitely bring you along when we look at it, if you remember, that's our airbag connector for the driver's side, because it didn't have a nice yellow connector like it should have, like the passenger side did. And remember, we have to account for that these seats aren't going to have airbags into them. So we've got to get the truck to either think the airbag is still there when it's not, or delete the airbag out of the configuration altogether. And if it works, I want to show you my plan for this one. It's going to involve a little bit of a breadboard and a little bit of a resistor, if that clues you in a little bit, but I'll bring you along and we're going to test that. And if it works, yay, great. I'll show you what the fix is going to be for that side. We'll have to repeat it for the passenger side. So again, just got a little bit more wiring to do, but I'll bring you back once we've got this tapped in, and once we've got our 2 ground wires over there extended, and we're ready to move on to the next piece. I'll talk to you in a bit. Bye. And welcome back. So you can see we've got our tie-in to our IHS can. So what we ended up doing, as you can see here, obviously we cut it here, and then we extended each of the pair on each side, and then brought each together and to kind of basically made a Y adapter, as you can see here, and then splice that into the harness that we needed here. And we went ahead and just did a quick check with a multimeter. So basically I pinned it between here and one of the IHS can pins coming off the radial harness, and was able to get connectivity, and also tested connectivity to this connector right here on the left hand side, which also these 2 pins, you'll notice it's white with orange and white with gray, are also part of the IHS can circuit. So we're able to get connectivity between this connector, our 14-pin connector, with the 2 pins, corresponding pins for the IHS can. And as you can see, we went through and put just shrink tubing ends on the ends that were going to keep a part of that connector but not necessarily use right away. Did the same thing on the passenger side harness, and went ahead and extended out the 2 ground cables that you can see right there also to come here towards the center. So what we're going to do, as we spoke about earlier, all the ground circuits, to include the ground off the new distribution block, we're going to just ground it right here to this existing body point. And we have 3 positive lines, all 3 of which come off of, well, not really, but 2 of which come back directly to the driver's side 14-pin connector. That was the ones that are going to be for keyed ignition. And then we have the splice point you see down there again, which feeds both the power seat controls for each, which also will go to the distribution block that we're going to put in the center. And you can see then we got some more work to do here, because eventually what I'm going to do is cut the tape and take off this protective sock just to get it back here, and that way we can take this wiring, bundle it all together, and wrap it within this same appendage, just so it's not separate. So we'll probably take this one and wrap them together, and then we'll take, actually we'll keep this one separate. We're going to separate out these seat wiring. This will be separate because it goes more towards that way for the central console. And then we'll take this unused ground, these 2 seat wires, bundle it together with this, and we'll get this wrapped up as well into kind of its own separate bundle. But we did secure it, as you can see here, with tie wraps, at least on those can lines, to our harness, kind of right where we spliced it. And yes, this is all soldered and heat shrinked up, as you can see, but we did zip tie it to the main harness just to give these connection points some rigidity, so they're not, you know, bouncing around and such and moving every time you move the harness and potentially breaking one of our solder joints. But as you can see, we've got a little bit of cleanup to do yet, but we got some more wiring to do yet as far as getting that central distribution block in there and getting the main power line run down this way, out, up, and out in the engine compartment, so we can tap off of the main fuse block. What we're going to be doing for our distribution block is what you see right here. Now, this is a bit overkill as far as the amount of current that this bad boy can support, but it's got a common positive rail that you can see there, which will come off the distribution block in the engine compartment. It's got a main negative rail, which we may not use the main negative rail right away because, again, we're just going to tap off of here and ground to that eyelet, but at least we'll have a nice grounding point and a spare fuse that we could use for something in the future, because we need 3 fuses. We need a couple of 20 amps and a 25 amp, one for each of the powered seats. I'm sorry, we need 3 circuits, as the powered seats, according to the wiring diagram from OEM, share the same fuse, and the 2 keyed ignition positives have their own fuse, and I think they're 25. I think they're all 3 maybe 25s, or one's a 20 and two's a 25. Anyway, we'll look it up with the wiring diagram and get the fuses changed out once we have this wired. But what's going to happen is that this distribution block is going to sit right here at the rear of the console, behind that rear panel, kind of just like this, and it gives us good access to be able to get to this just by popping the rear panel out in case we need to change a fuse. Now, remember I said we're going to have 2 of these 12-volt inputs that have to be keyed off the ignition. We're going to control that with a relay. So we're going to take, again, whether it's the rear feed or the front feed of the power port off the console, since that's a keyed 12 volts, that's going to drive a couple of relays, which will then serve to provide the power to these 2 pink and yellow striped wires here. So that's the game plan. That's what we're going to work on next. Now that we've got our CAN circuit tied in, we've got all the wiring that we weren't going to use capped off, started to get things cleaned up a little bit by getting kind of things zip tied here and there. So we're going to work on getting that distribution block in next and getting that main power line run from, again, we're just going to tap off of the spare battery positive post that's on the side of the TIPM and run it in here in the engine compartment. We're going to plan on snaking it down this way, much where you see the shifting cable for the transmission in this case. Just going to try to get it to follow this bundle to be on this side, not this one, because we go on this side. You know, I don't want to grab the cable and potentially pinch it down into here if someone's, you know, snapping the plastic back in place or the kick seal back in place. So we're just going to go here between these 2 pieces, come up, follow the wiring harness, you know, kick it 90 degrees, and then come down here and eventually meet up, and it will, you know, go in either the side entry point, hook up to that positive rail, or the other side. I'm thinking it's probably going to look best if we come into that side port and catch that lug right there for our positive rail. Anyway, it's kind of up in the air for now, but what we'll do is we'll get everything at least run. Obviously, we won't necessarily hardwire this in place because the console needs to be in here first, but we can do all our wiring here temporarily just to test things out before we put the carpet and everything else back inside the interior of this vehicle. But with that being said, I'm going to work on the next piece and I'll bring you back. Thank you much. And welcome back. So just following up on our wiring and continuing down this front is that you can kind of see just trying to get things tie wrapped up, trying to get everything situated and laid out kind of where it's going to run up to. And all of our grounds will eventually get a grommet put on it, and we'll get put on this center post here. And these positive lines will all run to that distribution block that I showed you earlier. But if you remember, two of these power sources that go to the seats, the driver's seat, which these two are smaller lines here, have to be key ignition. In other words, they're the power for the modules that control the heating elements in the driver's seat as well as the passenger seat. And now normally that would be handled by a set of relays in the TIPM in the engine compartment, in other words the fuse block on this particular Dodge. But it looks like this particular cab wiring harness that we've been looking at in the last couple of video segments, even though the fuses are in the TIPM for it, but that wiring just isn't extended elsewhere. So what I'm going to do is, what you see here is just a pair of what they consider Bosch relays. Now these are 5-pin relays, and most of the time when you pick up a 5-pin relay, it'll be called a Bosch relay, because Bosch was the ones that came out with a 5-pin relay. And this particular 5-pin relay has a dual pin 87 connector and not an 87A, and hopefully that focuses in and you can kind of see that. So on here you have a dual pin 87, which means you got two potential power feeds coming into this relay. Now I didn't buy these because it had two potential power feeds, or that we even needed an 87, dual 87s, or 87 and 87A. A 4-pin relay would have done what we needed to do just fine. But I got Bosch relays because it's a nice relay. I know it'll be reliable. And in this case, what we need to do is that this relay, if you also look at this symbol here, has a diode on it. Not all relays do this, but this particular relay is polarity sensitive because of that diode. And that diode is to eliminate relay chatter that may occur when you switch this relay off and that magnetic field or that coil collapses. It could potentially induce a current back into the coil and, kind of get this relay to chatter or to partially latch and unlatch again. But because of that diode, it is polarity sensitive when you go to actuate the coil in this relay. So I just went on Amazon and got some of these generic 5-pin relay holders. The nice thing about these particular holders is that you'll see they're keyed on this side, so you can actually take them and slide them into each other and make, once you get that seated all the way, and make, as many across as you need. And then in our case, we're going to have 2 relays, so we'll just slide 2 of these together, and we'll have them nice and locked together, and both relays side by side. But on this particular holder here, once we get our pins lined up, which will kind of look like this, it's a nice tight fitting connector. I like it. I did get some previous connectors, and I tried shooting this video once already. And the previous connectors I got, albeit they're a little bit more beefy because they're meant to carry up to 40 amps, the pin fitment on these connectors were just garbage. So I ended up having to find something else, because you could sit there and wiggle the connections and the relay would actuate and deactuate. So I ended up just having to find a different holder, which is this one here, and I can already tell you this one's much tighter fit on those pins. Now, what we need to actuate the coil on this relay is 85 and 80 pins, 85 and 86. And then when we actuate it, what will happen is it'll take pin 30 and allow pin 30 to be connected to pins 87. Now remember, this is a dual 87. And actually, I should say it that way. It allows pin 87 to then be connected to pin 30, however you want to say it. So what you could potentially do with a relay, now normally if you're looking at a 5-pin relay, sometimes they'll have an 87 and 87A, and what that means is when the relay is de-energized, it'll be open to one path, and when you energize it, it'll be open to the other. But since this has a dual pin 87, meaning this blue and this red should be electrically tied together. And let's test that theory. So we got a relay installed, and as you can see, it has no power source connected to it right now. So if we take this red and this blue, they should be electrically tied together on the inside of this relay. So we're just going to take our meter. You'll hear the tone there. And if we go between red and blue, you can hear that we got a tone on our meter. So those two are electrically tied together, and it'll be electrically tied together whether this relay is energized or not. And the reason why I'm going kind of in depth into this is just to let you know that when you're wiring your relays up, just pay attention to whether you got a 4-pin or a 5-pin, and if it's a 5-pin, whether you got an two 87s or an 87 and an 87A. Now, what should remain unconnected is between red and yellow. You'll notice there's no tone there. Also, there should be no connection between blue and yellow. Now you may be asking yourself, why would you want a relay in which these two wires, which would be your input wires, be tied together? Well, you may have a situation where you want to feed this relay with two different power sources based on whether something else is happening in the vehicle. In this case, you could do that. You can tie this to one power source and this to one power source and feed this relay via two different methods. But what we're going to do, since we only need one, is we're actually just going to clip this blue wire a little bit short and put a piece of heat shrink on it and just kind of, you know, not worry about it because we don't need it. But what we can do, and we got our little lab bench power supply here off to the side, and you can see it there, set at 12 volt and 1 amp. If I remember correctly, white should be our negative on this pinout. Yep, red's our positive. So hopefully you can hear that click. Now with that relay energized, if we come in here like we were doing before, and I'm sorry, I actually tested that incorrectly. I do apologize. Let's go back and test that again. So I went between red and yellow before, and I shouldn't have done that. We go between red and black. Do we get a tone? So relay de-energized, nothing. Now if we go between blue and black, also nothing. So let's do that again. Let's re-energize our relay. Apologies for that. So relay is re-energized. So now if we go between red and black, now we've got a tone. And also the same thing between blue and black, just to show you once again that red and blue on this relay are the same wire. They're they're electrically tied together. So now if we de-energize our relay and listen for the click, you'll hear no tone. So what we need to do for our wiring is, again, we're just going to snip the blue wire, put a cover on it, call it a day, and then this is going to be a feed off of our fuse block. So we're going to tie this into the junction block that you saw us do in a previous video, which is right here underneath our meter. So we're going to take the output of one of these fuses, go to there, and then this black wire is going to end up going to tie into one of the two 20 amp relayed feeds that we need going to our seat. So we're going to tie that together. This is going to come off our distribution block, and these two are what's going to actuate our relay. Now, where we're going to actuate our relay from, and I did look at this in the video, when the console sits here, it's got a power port in the back of it that's already pre-wired into the truck. If you remember earlier, we already had a wiring harness that was pre-wired on the driver's side. It has a source of 12 volts that's keyed. So we're going to tap into those wires to drive our relay. So that way when we got the key in the on position, these relays engage and they provide power to the heated seat module so you can turn the heated seats on. So yes, it means that with this fuse block and these relays will be kind of like this in a sense. So we will double sticky these relays to this fuse box cover, so it'll just kind of sit in here like this behind everything inside the console. And it means that we'll have to sacrifice that rear power port to drive our relays, but to be honest with you, I'm not really concerned with the back seats not having access to a power port, because 9 times out of 10, with everything being USB A, B, or C to power most devices, 9 times out of 10 you're going to plug an adapter into that power port anyway, which means there's going to be plenty enough adapters already in the front of the console that we're not going to remove, that we could easily just, you know, give somebody a USB feed from one of the front power ports via just, you know, a 6-foot or 8-foot or 10-foot or so cable. Now, what we can also do is that we're going to use three of the 4 fuses out of this block, so it leaves us an extra fuse. So we got some, you know, at least one future circuit that we can expand in, which will be nice and accessible again, right about in here somewhere behind that back cover of that center console. And what we could potentially do is wire in our own, you know, USB-C charging block and have it come out the back of the console and just use that spare circuit to do it. So what I'm going to do is get to work on a little bit of wiring here. I'm going to take these 2 lines, which again need to go to a relay each. One will go to one relay harness, one will go to the other. And then, like I said, I'm going to get rid of this one. We're going to wire into our black lead, which will go to our load, and our source will go to the red one, which on this one, I'll show you what I'm going to do here. Once I'll show it to you as we do as well. We just got a Ferrule crimping kit. We're going to crimp a ferrule onto that, which will do us make it an easier job to then screw it into one of these outputs. But I'll bring you along when we get to that step, just so you can kind of see what I'm talking about. See, I'm thinking that if we probably trim about half of the wires off of our holder here, and probably, I would say, cut these wires to about here, yeah, that's more than enough slack that we can kind of maneuver this around to where we need it, and go about from there. So I'm going to go ahead and work on this, and I'll bring you back when I get the first group of these connections done. One moment. And welcome back. So I promised I'd show you this little kit here. What I'm going to do for the pins that need to go into that fuse block. This is a Ferrule Kit. This is the crimper that comes with the kit. This kit does a very nice job of taking stranded wire like this. You just grab your appropriate sized ferrule. Get that in place, get that in place. Then take our crimpers. Very nice job, giving us a little metal tab that you can kind of see there. A little bit of wire poking out the end of it. I didn't quite trim enough of it off. But we can then take these ends and better get them fastened into the output ends of our fuse that you see here, and then be able to tighten this set screw down, you know, and basically give it something kind of more solid to bite into rather than just a bunch of stranded end wire. And to correct what I said earlier, again, it would have worked the way I was describing it, because it's not really backwards per se, but in order to keep with the wiring diagram of the relay, the source is going to come in on pin 30. So our 12 volt in is going to come in on our black leads here. And then when the relay is energized, it's going to leave on our reds. So we're going to tie reds, which is technically the relay out, into our trimmed wire here. And what I'm going to do here is I'm just going to make this a solder connection and seal it up with some heat shrink, and then I'll bring you back. One moment. And welcome back. So you can see we got our leads going to our control module for our heated seats, wired into what will be our outputs. We got our ferrules added to what will be our inputs. It'll come off our fuse block. And then we've got our relay controls. This will be the 12 volt input signal that actually actuates our relays. And we went ahead and hooked two of these relay holders together, and you can see it makes a nice little block there. So what we should end up with, so if we switch over our plug here so we can turn our lab bench power supply back on. That's just what you see over here in the corner of the screen. Current limited and voltage limited. Currently set it again 12 volts at maximum of 1 amp. Yeah. That'll activate both our relays now. We're pulling in 0.29 milliamps. And then if we take our multimeter, just to verify our work, and if we go between, let's grab our plug here, which goes to our driver's seat. And what I'm going to do, you won't be able to see it because it's off camera, but I'm going to probe one of the two pins again that gets this switch 12. And if you remember from a previous video segment in this video, that is the pink with the yellow stripe, and one of them looks to be right here on this pin. So if we go between there we go, that's on that relay, and then we should get nothing on the other relay, and we do not. But if I move the other half of the meter over to the other pink with a yellow stripe, make sure I get a good connection on this. And then come back with our meter. There we go. We got connectivity. It's beeping because I'm not solid on my lead. There we go. So we got connectivity there and no connectivity there. And if we turn our power supply off, here the relays disengage, and you'll see no more connectivity there. So perfect. So what we've done is that we've got a section of our relays wired in at this point. We know that we have good connectivity through the relay, through what will be our power inputs on these lines here, through the relay, through each one of these wires, and finally to each pin on the driver's side seat that those switch 12 volt inputs need to go into. Let's see, this line that you see here, we're just going to get it stripped out and put a ferrule on it as well. And what this will be a constant. This is the shared constant 12 volt feed that will also come off that bank of fuses, except it'll just go straight to one of the fuses. It doesn't need to be driven through a relay because the way the seats are designed, pretty much I think any electric seat does this, is that they'll work regardless of whether the key's in the ignition or not, provided that you've got, you know, battery power and your fuses and everything are good. So that, again, that'll just go straight to one of the fuses in the block. All right, so perfect. So that'll be the step we'll do next. Again, probably won't film it because it's just crimping a ferrule on it. You saw it in the previous segment. And then we'll get an eyelet together to tie these 3 grounds into, and then we'll run a ground when we get to it, but we'll go ahead and run another ground from here to this section of the block, which is meant to be where all your grounds can tie into. Now, obviously, we don't need it for what we're doing here because we're going to utilize the body ground, but we'll go ahead and wire this in as a ground source, so in the event that we need a ground accessible in the future, then we'll have it right here without having to, you know, go further or find another bolt to attach to. All right, so with that being said, I'm going to continue to work on this, and I'll bring you back. One moment. And welcome back. So we're in the process of prepping, after following our work from the previous segment of getting our relays partially wired in, running what will be our main hot and our main ground into that distribution block you saw earlier. So what I've done here is just removed this cover plate, which is generally up in here on these rams, just to show you. Got a nice big opening in there now. What that is usually there for is if you had a clutch in this vehicle, but since there is no clutch, they just block it off, but makes a very nice convenient access hole. And as you can see here, the previous owner did the exact same thing, where they also just kind of drilled through this to run some wiring. We're going to do that as well. Now we're just going to widen up this hole a little bit, big enough to take a grommet. You can see here I just got a kit of grommets. I'll put a link to this kit in the description. It's just from Amazon. Now, we're going to put in a 4 gauge. I believe this is 4 gauge. Yeah, this is 4 gauge, basically flexible, multi-stranded, what they call battery wire or welding wire. Now, we're going to go a little bit bigger. Now, as you can see, this grommet fits very nicely on that cable, but since we know we're going to be doing future work to this truck, aka adding a supercharger, and going to need to have basically a gauge package in here at some point in this pillar. At least I believe I'll put it in this pillar, and it's going to have various wiring that's going to need to go to sensors that monitor fuel pressure, boost pressure, so on and so forth. We know that we're going to use this same access port to get that wiring through. So we're going to drill a hole big enough for this size grommet. And as you can see, it'll still do a good job of protecting the wire, but it'll also give us, you know, a little bit of slack to sneak some additional wiring next to it. Now, even though this is plastic, I'm still going to drill a hole big enough to seat the grooves of this grommet into, because this plastic, even though it is plastic, it is rigid enough that if you get enough vibration over time, it could still cut through the insulation of this positive wire. And yes, 4 gauge wire is going to be a bit of an overkill as far as size, but I'd rather go ahead and put, you know, at least a little bit of a buffer in here as far as wire size, because then it gives us the ability to use that unused 4th slot in that distribution block for something in the future and not have to worry about, you know, pulling this cable out and putting in something bigger. So that's what I'm going to work on next. I'm going to go get one of my step bits, step through that until it's big enough to you know, get this grommet to seat, and I'm just going to basically get the groove that you see there in the grommet to fit the plastic here. And then we'll get this bolted back to the firewall, And then we'll continue to run our positive cable to our fuse box. And in case you're curious, it is held in with two 15mm bolts you see here that have the built-in washer, as well as the nylon lock piece at the top. Like I said, I like using this because it's there. It makes a very, very nice, quick, convenient access, and you don't have to worry about drilling another hole through the firewall or trying to snake your wire through some existing opening. So I'm going to go to work on this, and I'll bring you back. One moment. And welcome back. So I figured I'd show that to you real quick before I go to reinstall it, because it's a bit easier to see. But you can see we just drilled it out with a step bit until it was big enough to get the grooves of that grommet to seat inside the plastic. So now we've got that in there. Then we got a nice, secure, very protected entry point in for our wire. I'm going to get this re-secured, and I'll bring you back. One moment. And welcome back. So I'm just going to show you how we're placing our wiring here, just the way we spoke about in the previous segment. Again, just following this side of the cable tray, just staying away from this side of it, because this is the side where the plastic kick panel would snap in place. So I don't want to put it over here because I don't want to catch and pinch this. So you can see we're through. Get you some light. There we go. You can see we're through the grommet that we put in. Kind of pass it down off to the side behind our wiring harnesses here, following the same path as one of the wiring harnesses that kind of come down this way to meet up with this cable tray, and just kind of sticking to this side of the vehicle, so that way we minimize, hitting it or pinching it with anything. And since these wires are run in a relatively safe spot that don't get subject to abuse, again, that's why we're just kind of following our existing tray over here, cutting the corner. And don't worry, we will secure all this a bit better than what it is now. It's just roughly laid in here. And you can see once we finally get everything tied up, it's just going to loop around over to here, and then finally, get terminated to our junction block. Now, what we're going to do on the inside of the engine compartment is, when we make our main tap, we're going to have a fuse, and I'll show you that when we get to this step. But basically, we're going to have a fuse that's going to tap into our main battery positive that feeds our TIPM. So it's going to kind of come up like this and just tie into place. And now it may mean that we got to alter this cover a little bit and potentially just remove this little flap that would normally cover this up, in order for us to put a big enough eyelet in here to grab a hold of it. Now we can tap there, or we can tap right here, which is part of also just the main battery positive in general, and kind of go that route with it. Not quite sure yet which way we want to go with it, but what I'm looking to do, and you can kind of see it coming out of the firewall there, is that I want to run this, and basically, don't worry, we will put wire loom around this to give it a layer of protection, but I also want to run this and kind of keep it away from anything that might vibrate or move. Now, in the same breath, we want to make sure that this wire in here dangles down a little bit. And let me get you some light, because that would be a lot easier to see that. Yeah, it looks like it's coming in pretty good via the camera view here. Basically, we want this to come down a little bit and then over, because what I don't want to happen is if this wire is up higher than the hole in the firewall, if this wire should ever get wet or get moisture on it, the moisture could, in theory, follow the insulation down and go straight into the cab. But with this wire kind of dangling down, coming down a little bit of a turn, and then going forward to connect into something, then the water will just drip off the wire at the lowest point, should this ever get subject to, some type of rainwater intrusion, things of that nature. Again, just trying to look forward at and eliminate any potential issues before they become issues. So what we can do here is that we can just come up this way and follow our wiring harness, our main battery wiring harness here, kind of zip tie or hot wire to it, yeah, and then potentially just break this nut loose here and tap directly off of that post. So what we're going to use, and I'll show you that, what I've decided to use, because it is a fairly beefy sized cable, it could potentially carry quite a few amps. Let me get one out the box here. Here's one. Is this right here. Let's get this out of the package and show this to you a little bit better. So this is a nice big DC rated fuse, 75 amps at 58 volts. It is capable of quenching and breaking the arc on quite a bit of current, far in exceed of that. Use these on big battery systems. I mean big battery systems like solar battery systems, boat battery systems, things of that nature. And you can see this is what's going to attach the positive battery post. This is what our cable going inside the cab is going to attach to. So it forces it to go through the fuse, which is conveniently mounted as part of the stud. So awesome. And the reason why I went with this route is that this fuse will protect everything from the top of this stud forward via this fuse. So at any point in that length of positive battery cable, should it become compromised and ground, then this fuse will take care of it. Versus in some setups you see where they may have, like, you know, maybe this is our battery positive wire, and they may have a wire coming off a battery positive, and maybe it's like 2 or 3 foot long, and then they put a fuse in and then they carry on. Well, the fuse will protect everything from the fuse point onward, but it won't protect from the fuse point upward. So I didn't want to have that gauge of a cable, you know, potentially have a couple feet exposed, where if something would have happened and it would have short up here, then it would continuously short, you know, until the cable burned through. But this will help us, you know, basically protect as much as we can. So what we're going to end up with is potentially something that looks like that, maybe coming off the side of that battery post, and then having the wire for the cab terminate to this. And what we're going to use is, I got some 4-gauge copper lugs. We're going to crimp some 4-gauge copper lugs on there and secure it with some heat shrink. It looks like, yeah, we may have to trim the side plastic here a little bit in order for this to still close once our terminal's in place, but yeah, that should be fine. I actually think I'll do that. I'll look at going to this route directly first rather than coming down here and having to remove that little piece of plastic. Like I said, if it doesn't work out, then yeah, you can see that fits in there quite nicely. But we would have to trim off this little covering door that kind of covers this and keeps debris and stuff out of this fuse box. So if I can avoid it, we'll avoid using that connection point at this point, and we'll just come over here and maybe do something again like this. As you can see, trim this little piece of plastic here on the side, and that will still allow us to snap our positive battery cover in place. And I don't see where that is going to stick up too terribly high and cause any issues with hitting the hood, because you can see the brake reservoir, you know, sits up higher than what this is going to sit. And basically, you know, the brake reservoir obviously isn't hitting the hood, then neither should this. But we'll keep an eyeball on it. We'll make sure that, you know, this top post here isn't going to dig through the insulation once the hood shuts. and then we'll go from there. You know, if we have to, we could potentially do that there and just come on the side of this battery post. And I'll have to play with it a little bit and, you know, figure out what the best solution to this might be. The best solution, if it'll let me do it, if we take, I don't necessarily want to do this upside down because you'd have to remove this nice little, you know, insulative cover to get this in there. Yeah, it's not going to work that way. Like I said, it may end up being here off to the side, or it may end up just being down here for safety's sake. I'll have to think about it. But anyway, that's the game plan. But you can see there, you can get these on Amazon. I'll put a link in the description. But in this case, you know, we're just going to use a 75 amp 58 volt. And the nice thing about these square fuses you see here, you undo this nut, you can pull this fuse off to easily put a bigger one on here, or to change this out. And like I said, it will protect everything from the stud forward. So with that being said, I'm going to work on this and I'll bring you back in a bit. Bye. And welcome back. So you can see we got our end crimped on here, and I'll show you what I was using. It's just one of those little hydraulic crimper kit sets that I've used to make several cables in the past. It's one of these little small handheld kits. There are quite a few of them on eBay. I'm sorry, not eBay, but Amazon. They're all made by different manufacturers, but I think they all actually come out of the same manufacturing plant, if you ask me. And supposedly they're rated for about 10-ton crimping capacity. Now on this one, I had to go down to a size 15 die, as the 25 die was a little bit too big, and it didn't come with a 20 die in the kit. So 15 die was the next smallest size down, and it gave us a nice secure crimp. You can tug on that pretty good. That connector's not going anywhere. So to finish it off, just got a little piece of heat shrink tubing here, and this is the type of tubing that also has the sealant on the inside of it as you heat it up. So we're going to get it on this cable, get that sealed up, and move on to the next piece. One moment. And welcome back. So you can see we got our end heat shrinked in, and you may be able to even see the sealant kind of coming out of the heat shrink, which is what we're looking for. So we've got it nice and heated up, nice and shrinked in, got the sealant to flow in, so all that looks good. And I just got this taken apart here and prepped for where we're going to put it. So just to show you a little bit more on this, so that's your fuse section. You notice you got a contact plate there and a contact plate there. But if you look at this piece, there's an insulator between this center post and this post here. So this center post actually doesn't conduct any electricity. It's just there for mounting. So we take our fuse like so. It goes down over the top and just tightens in. So what's making contact is the contact plate on that side of the fuse, and that round contact patch you see there on that top of the fuse. So I think after thinking about it a little bit, I'm going to go ahead and go with the first plan here, which is just installing it on that battery feed there on the side of the TIPM, because it gets it down fairly low in the inch compartment. We don't have to worry about it sticking up, although again, I don't think it would stick up too far to cause us any issue. But we also don't have to worry about anybody jump starting this thing or changing the battery out who may not be us having to worry about an additional appendage attached to this cable. So again, we'll have to trim off a little bit of plastic off this covering door here to account for our deal here, but it shouldn't be too terrible. Yeah, we may have to, like I said, just kind of cut this even, but we'll find out here. We'll find out here in a moment. I'm going to get that bolt crack loosed and set that down in there, and then I'll bring you back in a moment. And welcome back. So you can see how it ended up. I'm actually very, very happy with this fitment. That connection point was just long enough to allow the fuse section to hang just outside of the fuse box so we can attach to it. But you see, you can still get your fuses off and on that back stud. There we go. And you can see the trim that we did to the rear corner. We just took that flap that was sticking off down off of this and kind of flattened that out. And you'll notice when we close it, that we can clip, we can close. That comes out just rather nicely right at the start of that fuse there. And let's see, we may have to trim a little bit more of the fuse block off. Let's see, because this is going to be our cable from inside. Yeah, no, that'll be perfect. Yeah, we don't have to do any more with the fuse box lid. You can see there we're in the clear. We're going to tighten this down, and then we should be good. That came with a washer, lock washer, and finally a nut. Now, I know what you're thinking. There is a protective cap we need to put on here. I did have to remove the protective cap because it did have like a little lanyard piece that went onto this flat piece of metal to hold it, and it just wasn't enough clearance in there to get that in there. But what I did do was just trim off the little hold down piece that was there, kept the cone part of it, and what will happen is once we get that bolt tightened down, then this cone part will just push down over on top of this. Is kind of as you see it doing here. I may trim this cone part a little bit just to kind of go down over on top of the connector and back so it lays a little bit more flat, but then that should do it. Okay, that should do it. That'll give us a nice sturdy fused from the stud point forward connection going into our cab, which again will run our heated seats and our powered seats. Now what I may do, you see me just kind of looking at things and turning the cable, so I may just turn the cable this way and tighten it just so it's not sticking out this way towards the engine compartment. Yeah, I'll do that. That looks a little bit better turned inward. And of course we'll pull this slack through to the other side and get everything kind of nice and secured and buttoned up out here. And then I'll bring you back when we're back inside the cab. One moment. Welcome back. So just to show you that before we move to the inside of the cab, we've got it tightened. I did notch that cover, as you can see there a little bit, just so that little flap would come forward and cover up that last little bit of copper there. Now I may come in here and you know, maybe wrap a small piece of electrical tape on that as well. I think I'll do that and then put the cover back over it just to give it some extra protection. But I'm happy with that. Like I said, I'm gonna pull this this slack and this cable back through the wall there, and I'll bring you back. One moment. And welcome back. So just want to show you a little bit of what we've done with our wiring here. Is that we got ourselves a ground wire. Again, this is 4 gauge, just like what's coming off the battery positive you saw earlier. And I'm going to change things up a little bit. Rather than go to this center lug that we originally planned onto it, I decided I don't want to break that loose, since it's nice and secure and currently providing a good grounding point to the existing wiring coming out of the harness. I don't want to break contact with that and tighten that up, albeit I don't think it would bother anything. I got to looking at this, and remember the back bracket is going to sit right here, and it's a pretty meaty metal bracket. It goes from here to here for the back of that console. Bolts in here and bolts in here. So this will actually provide us a very nice grounding point back here. So what I did was just cut a small piece of the 4 gauge, except in black this time. And what will happen is, this will bolt down to a bolt that'll also be on that bracket. this is going to curve around and hook up to our negative rail on our distribution block. Then on our positive, a couple of different ways we can go on positive. Once it's back here in the console, you can either go here on this side and hook up with this lug, or we can run it down, around, through here and go to this side lug. Either way. And what we'll be doing in both cases, just so that we're not taking a big wad of stranded copper and putting it inside one of these set screws and screwing it down. Although you can do that, and that would work fine, provided you torque your set screws down. We are going to take a ferrule, of which I don't think I have them in here with me, but I'll show them to you when we get done with them. It's basically a bigger version of these little ones you see here. I have some that'll go all the way up to 4 gauge, and we'll crimp a ferrule on this. That way it keeps all these little individual strands all tied together in one nice little metal tab, kind of like you see here what we did with all our grounds. We took our 3 ground wires that we had, put them in the one ferrule and crimped it. So it'll kind of look a little bit like this, but it will allow us to tighten it in on these screws, and it'll be a metal to metal contact, solid piece of metal, rather than a wad of stranded cable. Let's see, so to give you a little bit of idea, you see our negative is going to attach here, and remember this is all going to be mounted in the back of our box, back of our center console, probably about somewhere, maybe about right into there. And then, since we're not going to use our center ground point, that's why we put all of our grounding leads we had, which we had 3 of them. We crimped them all into one ferrule, and then all we have to do to this ferrule then is undo that set screw and tighten it into this negative rail here. And then our positive feed, this will be a positive feed for the power seats for both left and right driver's side. And then we have our 2 power feeds off our relay pack. So these 2 here, that'll also go to one of these fuses. So we're going to end up using 3 of the 4 fuses like we spoke about earlier. We will get these changed out. I did buy a pack of other size fuses because we only need, I believe it's either 220s, I think it's 220 amps and 125 amp. The 220 amps go to the 2 relays, and the 125 amp goes to the heated seats. I'm sorry, to the powered seat controls, if I remember correctly. That could be the other way around, but I'll correct that if that needs correcting. I'll explain that a little bit more in detail once we get the center console in here and we're ready to get this mounted and then wired in place. I also got a little bit of piece of loom, just some cable wrap loom, standard split loom, I guess you could call it, that we're just going to take and put on our positive lead, so at least is wrapped from about this point where it comes down through here and up to the point where it hits the distribution block, just to give this wire some additional protection, so it doesn't inadvertently slap around and come into contact, or rub through the jacket, come into contact with some piece of metal. So we'll do that. We need to finish cleaning up our positive line as it runs through our wiring harness, so we'll get a few, and we also need to trim these zip ties as well. We'll get those trimmed, but what I'm showing you here is I want to go through here and zip tie down this positive lead to the existing wiring bundle. Again, just cleaning it up. We're gonna get some cloth loom tape around here. We're gonna cut this jacket off of here and get all that rewrapped. Just kind of give you an idea of the items that we're going to take care of, and I'll more than likely just take care of all the cleanup stuff off camera, but I'll bring you back in the next video following to this once we get the dash installed, and once we're ready to get to this point and obviously put the seats in. I'll show you what kind of all that wrapped and loomed cable. But I think the video at this point is done for this one, because it covered the bulk of the wiring that we needed to put in to get our heated and ventilated seats to function, to get the heated seat module to talk to the correct internal bus, so that way when we program the truck, we'll be able to control the heated seats and the ventilated seats from the switches, which will be mounted in the center of the dash, again using the native OEM switch bank. Showed the wiring of our relay pack here that we're going to use to provide our keyed 12-volt source to our heated seat modules, because we needed 2 of them, as well as our continuous battery positive line here, which is for the physical movement of the seat. And then we covered putting in this 4-gauge positive lead, which is a hot lead directly from one of the side accessory battery posts on the side of the fuse box, all the way in here. So we also showed you how we just utilized that little black piece of plastic that would normally, it's covering up the hole that would normally be there for a clutch pedal rod. We're just using that to run our wiring through. So really the only thing that's left as far as the wiring is getting things cleaned up, situated, zipped down to the looms, and get some loom wrap in here to wrap things up a little bit, and then we can make our final connections. As far as the connections, it's going to go into a distribution block once we have the console in here and have something that we can mount this distribution block to, and then we can proceed forward with the final bits and pieces. Now, in the previous segment, we did verify that we do have connectivity when these relays close to the affected pins on the 14-pin connector on the passenger side seat in which they need to go to. So we know our wiring is sound from our relay pack all the way to our seat connector. So I think at this point, I'm going to call this video for wiring at an end. And then when I bring you back, we're going to go over and cover putting the dash back in. Now it'll be the dash for the 2010 Ram going into this 2012, because if you remember, when we took the carpet out, the dash was still in. So we could at least get the dash, all the center console controls, all of its electrical plugged back up and replumbed, and get a substantial piece of the interior put back in and taken care of. And that kind of gets the steering wheel remounted back up and out of our way, and gives us a little bit more working room in order to get the carpet in here. So that'll be the next one. We'll get the dash put in, we'll get that squared away. Following that, then we'll put the carpet in. Once the carpet is in, then we can start to go through and put all of our floor trim pieces back in. Our pillar trim pieces can then go back in, and so on and so forth. So that's where it sits. I know this has been a bit of a long video, and this looks a little bit more daunting than what it is. And don't let the myriad of tools you see in the cab here kind of intimidate you. It's literally just the soldering station, multimeter for testing, lab bench power supply for testing the relays. You got solder, you got connectors, strippers, things of that nature. I just got a lot of stuff strung around here. So again, don't let the wiring intimidate you. It can be done. Just be slow with it. Just verify that you are doing what you think you're doing, that you're using the right wire pairs and such. But again, if you feel uncomfortable with the wiring aspect of this, then please see if you've got a friend of yours that may be able to do it for you, or just take it to somebody and have them do this piece for you. And this distribution block, if you remember, we're putting this in because even though the fuse box in the engine compartment of this truck has fuses for heated seats and powered seats, it doesn't look like the wiring it was at least included on the cab loom, because it does have a big distribution block here on the driver's side that plugs into it, that mates up with the engine harness, and it also has some wiring that comes directly in that isn't on a connector. Not sure why, but that's how they chose to do it. And even though the fuses are in the fuse blocks, it doesn't look like the wiring was extended forward. And that is one thing that we could have done, just to be fair. We could have taken the tip of them apart, we could have taken the plugs out the bottom of the fuse box, pinned out, either added wiring where there wasn't wiring, or traced the wiring down, figure out where it stopped, and then extended it, and used the relays that were in the TIPM rather than supplying our own relays. But for me, it was just easier to run our own distribution block for the powers and grounds that we needed, instead of, ripping apart a good majority chunk of the harness just to add in, the one or two pieces that were needed. With that being said, if you have not subscribed to the channel already, please consider doing so. It does help the channel immensely. For those of you who have subscribed already, I thank you. And with that being said, I will bring you back on the next one again, which should be us reinstalling the dash at that point. And I will let you go. Thank you much. Bye.